Okay, our last bit of this video is tangents and normals to curves. So we're going to start off with the normal. Now the normal at P is the line through P perpendicular to the tangent at P. And you know that if a line is perpendicular to another, then the gradients of those lines are going to be related by, if we multiply the gradients together, we're going to get -1. So for example, we noted the gradient of the line perpendicular to another with gradient 2 would be -1/2. Okay, and so equations of tangents and normals are found using gradient intercept form. So that is y minus y1 is equal to f lots of x minus x1. So basically, once we've found our gradient and we know what point we're working with, okay, we just substitute it into the gradient intercept form, and that gives us our equation for the line, which is awesome. So let's jump in straight away and have a look at some examples. So we've got find the curve y is equal to f of x, where f of x is equal to x minus 3 all squared. And what we're going to do is we're going to find the equation and angle of inclination of the tangent at 4,1. Find the gradient and angle of inclination of the normal at A and draw a sketch. And find the x-intercepts of the tangent and normal by using their equations, and find the area of the triangle formed by the tangent, normal, and x-axis. So quite a bit to unpack, but let's just start with part A. So part A is to find the equation and angle of inclination of the tangent at A. So we're already used to this, okay? So we've got our function, and our function is x minus 3 all squared. What we're going to do is we're just going to expand this out. Okay, I'm going to get x squared minus 6x plus 9. Okay, so a nice and easy function to work with. Now, what we're going to do is we're going to take our derivative of this function. Okay, so that's going to be 2x minus 6. And now what we're going to do is we're going to work out what the tangent will be at that point. So our point is 4,1. So what we're going to do is we're going to write at 4,1, okay, because that's the point we're working with. At 4,1, our f dash of x is equal to, our f dash of 4 in this case is equal to 2 lots of 4 minus 6, which is equal to 8 minus 6, which is equal to 2. So our derivative at that point is equal to 2. So the tangent at the point, and our point is 4, 1, is, okay, and this is where we're going to substitute it into that equation. So we're going to go y1 is equal to m lots of x minus x1, okay? So remember, y1 and x1 is this point up here. So this is our x1, this is our y1, and our gradient is 2. So we're going to go y minus 1 is equal to 2 lots of x minus 4, okay? And if we just expand and rearrange, we get y is equal to 2x minus 7, okay? So minus 8, add the 1, minus 7. Okay, so that is the equation of that tangent. Now for the angle of inclination, so for angle of inclination, what we're going to do is we're going to solve our tan alpha is equal to, and in this case it's going to be our gradient, which is 2. And remembering that it's between 0 degrees, that's not what I want alpha, and 180 degrees, okay, in this case, because remembering that it's always going to be above the x-axis or between the x-axis and between the line and the right side of the x-axis. Okay, so solving that, we're going to get, okay, tan alpha is equal to 2, take the inverse of both sides, I'm going to get that alpha is equal to, and if I look up here, I'm going to go tan of 2, and I feel like we've done this one before. We're going to get 63 degrees. Ooh. 63 degrees and 26 minutes, like that. Okay, so that's our angle of inclination for our tangent. And so that's all we need. Find the equation and angle of inclination. Done. Okay, find the gradient angle of inclination of the normal at A and draw a sketch. So at this point, Okay, so at the point 4, 1. So we're still at 4, 1. Okay, we're going to need to take we need to work out the gradient of the normal. So the gradient of the normal is just equal to the negative reciprocal of the gradient of the tangent. So the gradient of the tangent is 2. So our negative reciprocal is negative 1/2. So that is what our it's going to be. So now to do the equation. So equation. Okay, we're going to again use this y minus y1 is equal to m lots of x minus x1. Okay, so substituting our points in here, we get y minus 1 is equal to, now we're going to put the negative half in here this time, x minus 4. Okay, so same values, except the gradient's the only one that changes. So this time I'm going to expand it out. So we're going to get negative 1/2 x, and then it's going to be plus 2. So add 1 to both sides, we're going to get y is equal to negative 1 on 2x plus 3. Okay, and so that is the equation of our tangent. So our next step is to then work out what our angle of inclination is. So angle of inclination, what we're going to do is we're going to let beta, or sorry, what we're going to do is we're just going to solve tan beta is equal to, and in this one it's negative 1/2. Okay, so negative 1/2 for this one. And again, it's where beta is between 0 and 180 degrees. Okay, so what we're going to do is we're going to take the negative tan the inverse tan of both sides, and we're going to get that beta is equal to, that's going to be negative 1/2, and make sure we add it to 180 to make sure we get our proper angle. I'm going to get 153 degrees and 26 minutes. Okay. So that is our 2 different angle of inclinations. Now we should notice 63 degrees 26 and 153 degrees 26. If we actually put that point 26 and we subtract it from our other one, what you should notice is that when we subtract them, we get exactly 90 degrees. And we know that that's going to be 90 degrees because remember the angle, the normal and the tangent are perpendicular to each other. And if they're perpendicular to each other, then that means that the angle between them should be 90 degrees, which is what I've just shown here. So the 2 angles differ by 90 degrees by the exterior angle sum of a triangle theorem, if you want to get into the details. Okay, part C. So find the x-intercepts of the tangent and normal by using their equations. Okay, so part C. Okay, so to find x-intercepts, I hope we remember what to do. Let y be equal to 0. Okay, so what we're going to do is we're going to start off with the tangent. So the equation of the tangent, and actually just do the normal next to it. So we'll start off with the equation of the tangent. So the tangent's up here, and it is y is equal to 2x minus 7. Okay, now to find the x-intercept, we're going to let y be equal to 0. So we get 0 is equal to 2x minus 7. So 7 is equal to 2x, and in that case, that x is equal to 7 on 2. Okay. Now our equation is 1/2 x plus 3. So y is equal to negative 1/2 x plus 3. It should be negative 1/2 x plus 3. Okay, and again, we're going to let y be equal to 0. So we're going to get 0 is equal to negative 1/2 x plus 3. Subtract the 3. Okay, and to get rid of the negative 1/2, we're just going to times both sides by a negative 2. So that's going to be x is equal to 6, just like that. So there's our 2 x-intercepts. So therefore, x-intercepts, or the x-intercept of the tangent, equals 7/2, and normal equals 6. Okay, and that's all we need to do for part C. So nice and easy, just a little bit of substitution, which we've known how to do for ages. Now the last bit, last bit's the tricky bit. Find the area of the triangle formed by the tangent, normal, and x-axes. Okay, so what we can do is we could draw up the original function, or we could just draw up the tangent and the normal because we know what they look like. So I'm going to use red for my tangent. I'll use green for my normal. So my tangent is y is equal to 2x minus 7. So let's say it's the minus 7 down here. Okay, so 2x would mean... You know what? I'm going to actually do this one properly, I think. Because I think it'd be better if I did do it properly. Well, we know our x-intercept is at... Our y-intercept is at -7. Okay, and our x-intercept we worked out just to be at 7/2. So that's what, 3.5? So what about here? So 3.5 is 7/2. And our normal is at 6, so somewhere over here. Okay, and the gradient for that one is, or the equation for that one is +3. So it's up here somewhere, okay? So first equation goes, and I'm going to draw this one hopefully correctly. Something like that, except a bit lower. Wonder if I can... I don't think I can. Oh, yep, I can. Haha, cheating, my favorite. Okay, there it is there. So that's our first one. And our second equation is this one that goes like... Okay, definitely redoing that one. Okay, it's a lot shallower than what I am currently drawing, which is quite annoying. There we go. Oh, that was a really good one. Okay, so we're going to find the area of the x-intercepts where it crosses over, and the x-axis. So that's this bit in here, and I'm not using that. That's disgusting. Okay, so basically it's that bit in there. So how are we going to do it? Well. We know that this point here, okay, this point here is that point where the graph is, because it's where the tangent and the normal cross over, okay? And so if we were to draw our original function, that's the point there where they both are, because we know that the tangent, well, we've drawn the tangent or the gradient at that point of the function, okay? So we know the point here is going to be our point back from up the top, and our point from back up the top is 4, 1. So we know it's 4 long and 1 high. Now the 1 high is the main bit, okay? We also know that this triangle is 2.5 units long. Okay? So if it's 1 unit high and 2.5 units long, we can work out the area quite easily, okay, by just using the area of a triangle, okay, which is a half the base times the height. Nothing too tricky about this, okay? So the height is 1 unit long because we know that the point here, okay, that point there is at 4, 1, so it has to be that 1 unit in length high while it's 4 units long, okay? So our height in this case is equal to 1, and we know that the difference between the two x-intercepts is equal to 2.5. So that's what, 5/2. Okay, so my area in this case is going to be 5/4 times 1. So the area is equal to 5/4 units squared. Okay, that's it for this topic. So a bit trickier, that last one, but it's stuff that we can do and we know how to do now, okay? So what I would like you guys to do is make sure that you practice these differentiation skills, okay? Because they come in really, really handy later on. Okay, and the more that you practice the actual skill of differentiating, the better shoes we will be going into the later topics. So with that being said, that's the end of this video, and that's the end of this little sub-series for, what are we doing? The derivative, I think. The easy derivative, the simple derivative of f of x. Oh, well, x powers, I should say. So with that being said, we're going to be moving on to a different type of notation for our derivative in the next video, which is going to help us with a lot of things, again, that happen later on down the line. So with that being said, I'll catch you guys in the next series.